to JMath.
So now that you know the long way to do calculus, let's look for a shortcut. If I can tell you a fact about mathematicians, if there's a shorter way to do anything, we're going to look for it and we're going to find it. Mathematicians are some of the laziest people you'll ever find because they're always going to look for a shortcut to make things easier. And first principles is the best example in math. There must be a shortcut. You can't do such a massively long sum every time someone asks for the derivative. So on screen now, you will see a few sums that we did the long way with first principles, and these were the answers we got. Someone looked at this and they thought there must be a pattern. Let me teach you that pattern. The shortcut is called the power rule. Now, if you study further studies or AP math, you'll learn about the chain rule and the quotient rule and all the other things. For normal pure math, you only need to know this one rule, but its name is the power rule. So there's the steps that you can read and follow, but let me just explain quickly what you would do. So you would take the number at the back, so this n, you would multiply it by the coefficient, and then you would minus 1 from it. Let's do question 1 so you can see in action what it's going to be. If my sum starts with an fx, the derivative would be written with f prime x, or f with a little apostrophe. I would take the 4 at the back and I'll multiply it by the 4 in front. So it's 4 times 4, x, and then 4 minus 1. So my answer would be 16x3. So for question 2, I would take the exponent multiplied by the number in front. That would give me minus 6. And then from the exponent, I would minus another 1. So that would give me minus 4. Now, depending on how strict your teacher is and how old school they are, some teachers would say you can never have negative exponents. So therefore, the answer would look like this. But recently in textbooks and memos, they don't care. And you can leave it with negative exponents. So please just check with your teacher what she prefers. I don't want you to lose marks. Please just follow all the steps. Even though we're using a shortcut, make sure your answer is correct. For question 3, so the derivative of this f would be equal to, I would take 14 times 2, so 28x to the power 1, and then minus 4 times minus 1 gives me plus 4x, and then minus 1 gives me minus 2. And now I gave myself a massive sum, 12 times 13, so we know 12 times 12 is 144, so then this would be 156x12. There we go. That's the final answer, unless you need to write it with positive exponents, so then it would just be 28x plus 4 over x squared plus 156x12. Question 4, what happens if there's other variables in the sum? Okay, we are only interested in x because there is a x in the bracket. So if there's an a and a b in the sum, I'm just going to treat it like a normal number. So to get the derivative of this f, I would just say minus 1 times minus 3 gives me positive 3x to the power minus 4. There's an a in front, but in front of the a there's a 1. And then with the x, the exponent, there's an invisible 1. So I'm just going to say it's a times 1, which would just be a, and then it's technically x to the power 0 because I subtracted 1 again. Now, I do not need to write the x because anything to the power 0 is just 1. Okay, for now, I'm just going to leave it there. And now something very interesting that you need to know. If my original does not have an x in a specific term, then it means there's an x to the power 0. And that means I'm multiplying something by 0, so the b would just turn into a 0 because there's an x to the power 0, and the 5 would turn into a 0. So, something you will notice. In every term that I did thus far, from question 1 to 4, the x's became 1 less each time. So if there wasn't an x in the original, then there would be 0 in the derivative. So remember that. A constant term that doesn't have an x will not be part of the derivative. Okay, so my final answer for this question, let me just write it on the side, would then be 3 over x to the power 4 plus a. I hope that makes sense. Don't want to confuse you guys by going too fast, but it's just these simple rules. I subtract 1 from the x, and therefore if there was no x, I multiplied by 0, so that cancelled the term completely. Question 5. So now I'm not working with x, I'm working with s. So the derivative in terms of s would now be a half times minus 2 actually gives me minus 1, s minus 3, and then this would give me minus... Now watch out, I almost made a mistake. I am only interested in the s's. So that one, and then that one. The other terms do not have a s, so they would not go to my derivative. Just like the b and the 5 up top, if it does not have the term that I'm working with, it does not go to the derivative. So now I'm only looking at the last one. This would be minus 2 times 3 gives me minus 6. The pi can stay there, and then this is just s2. Let me just make this s a bit bigger as well. And then my final answer to this would be minus 1 over s cubed minus 6 pi s squared. So I'm only interested in the exponents of the variable in the bracket. Now, unfortunately, it cannot stay this easy. So this is why they call this section the rules of differentiation. So there's a few things you need to look out for before you can do the derivative. So let's look at all the rules of differentiation. So the first thing, you cannot derive if x is in a bracket. So there's an x, but it's in a bracket, so I cannot derive. So I must firstly FOIL out to make sure I have an expression with no brackets in it. Then I can get the derivative as I indicated in blue. Okay, so that's the first thing. X cannot be in a bracket. Now, x cannot be in a root. If it's a square root or a fifth root or any root, x cannot be in a root. I need to rewrite it in exponent form. Now, remember, if I can't see anything in front of the root, there's a 2. So I can rewrite the square root of x as x to the power of half. And with other bigger roots, or smaller roots in this case, whatever is on the inside with x goes on top, and the root's exponent goes at the bottom. So that's why that one changes into x to the power 2 over 5. Now I can just do my calculus, and that is how I get the derivative. The third rule for differentiation is x cannot be in the denominator. If it is, I need to move it up. So that's why this is x to the power 1, and my exponent laws says if I divide two similar bases, I subtract exponents. That's why this is then a 5 minus 1. The same with the next one. I firstly get rid of the root, so I make it a half, and then I move it up. So because there was nothing there, it now changes just to 0 minus half, and that's why it's x to the power of half up top. Okay, guys, I hope this makes sense. So it cannot be in a bracket, it cannot be in a root, and it cannot be in a denominator. There's 2 more. So it can also not be part of a big fraction. So the one on the left has 1 term in the denominator. Please be very, very vigilant and look for these things. So if it is a big fraction with 1 term at the bottom, I just split this into 3 separate fractions and then take up x in each case, and then I can do the derivative. The one on the right is a bit more tricky because now I can't just take up the whole thing or put a bracket around and take up. So if there are multiple terms, normally a binomial at the bottom, I need to factorize, and then always the denominator would cancel out with one of the brackets. And then it's actually a very easy derivative sum. Okay, guys, so the 5 rules for differentiation. Sometimes some books group them together and say there's only 4, but as long as you just sort out each of these 5 issues, then you can get the derivative. But wait, there's more. They are also going to be very strict with notation, they call this. So you need to check how the sum starts with the question, and then you need to continue in a very specific way. So you would notice I did the same question 4 times, but each started with a different notation. So let's just look at this clearly. So if a sum starts with fx, then the derivative would just be f prime x. I just put a little apostrophe. If my sum starts with a y, then I need to, when I'm ready to do the derivative, I need to say it is dy over dx. So the top variable will always be alone on the left, and the bottom variable is the one that I look for in the exponents. Like we saw with the first 2 questions we did, I look for those exponents, and anything else I ignore. So dy over dx, I need y alone, and then I'm just going to take the exponents of all the x's to do the sum. The bottom 2 are a bit weird, but if they start your sum with a dx and a big block bracket, okay, I simplify and I leave it in the block bracket just like it is. And when I'm ready to do the derivative, everything falls away and it's just an equal sign. The same with the other one where it's d over dx, also with a big block bracket. They are the same, even though they look a bit different. Now, something you need to know is all 4 of these mean exactly the same thing in grade 12. If you go and study calculus further in engineering and actuarial sciences and programming, then each of these means something different. In grade 12, there's absolutely no distinction between them. It's just to catch you out and see if they can take away a few marks if you mess this up. Now, normally in an exam, they can take about a maximum of 2 marks away for the entire calculus sum if you mess this up. But please don't let them take it. Study, and then make sure you get your full marks for notation. Let's now apply these rules and just look at the notation and see how it's going to be. Question 6. So I firstly need to see, is there something I need to simplify? Yes, there is. So I'm just going to keep it fx for now. And then the first one is fine. The next one, if I take up those 3 x's, this is going to give me plus 2. And then it's x 1 minus 3. So that becomes minus 2. So now if I do the derivative, let's do it in a different color. Then the answer would just be 4 times 4 gives me 16. X and then 4 minus 1 gives me 3. For the next one, 2 times minus 2 gives me minus 4. X minus 3. So then the final answer for this one, like I said earlier, you don't even need to do this step. If your teacher says it's fine, she is not going to subtract marks or negative exponents, then you don't need to do the last step. I know in the matric memos, they don't care. So do whatever feels right for you. Question 7. Now they're starting me with a y. So there's a few things I still need to simplify. So I'm just going to keep it as y equals. Now the 4 is going to stay there. Now this is going to be x to the power 4 over 3. So the inside exponent goes on top. The front exponent for the root, they call it the index of the root, that goes at the bottom. The next one, so this would be 2 and then x, 1 minus 3 over 2. So that's a bit of a complicated one. There's an invisible 2 for the square root, so that's why it's a 3 over 2, and I'm taking it to the top. So I just need to simplify that one more step. So this stays like it is. Please don't start deriving the first part and not the last part. It must all happen in the same step, otherwise you lose marks. So now, what is 1 minus 1.5? That would then just be equal to minus a half for that one. Now I can get the derivative, and if they started me with a y, I need to write, therefore, dy over dx would equal to 4 times 4 over 3. It's not a nice number, but it's going to be 16 over 3x, and then 4 over 3. Let's just do this in 2 steps. I can also just subtract the 1 there. The next one, plus 2 times minus a half, gives me minus 1x, and then minus a half, minus 1. So my simplified form would then just be dy over dx would be equal to 16 over 3x a third minus 1 over x to the power 3 over 2. Okay, they started me with the y, and therefore that's the notation I need to end with. The next one is now that big notation with brackets. So in this case, I would just keep the notation as it is for now and just simplify in this block bracket. So I need to write the brackets twice. I need to FOIL them and then multiply the minus 2 in. Just for safety, I'm not going to do it in one step. So 3x times 3x gives me 9x squared. Then multiply them, but times them by 2. So 3 times 3 is 9, times 2 gives me 18x, and then plus 9. Okay, the bottom part, I can rewrite that as 2, and then x 3 over 2 minus 1 over 2, and then close the block bracket. Therefore, d over dx, block bracket still, I need to multiply in the minus 2, so minus 18x squared minus 36x, and then minus 18 plus 2, and then that is actually just 1.5 minus half just gives me 1. Yeah, that turned out well. And therefore, I can now go over to the derivative, and that would then just be an equal sign. So with this notation, the block bracket just falls away, and it just changes into an equal. This would then be minus 18 times 2 is 36x minus 36, and now it was x1 minus 1, so it's x to the power 0. I am just going to keep it like that. The 18 doesn't have an x, so I immediately know. Okay, just don't, in your test, don't scratch it out like that. I just wanted to do it for you guys, but rather not. So the 18 doesn't have an x, so it's not even going to the derivative. And then lastly, plus 2, and then times 1 just gives me a plus 2, x to the power 0, so I don't need to write it. Final answer for this would then be minus 36x minus 34. Let's just look at 2 more. So now it's dt over ds. Now, like I said in the other one, I now want all the t's, the top variable, I want alone on the left, and I'm going to look at the exponents of the bottom variables, in this case, the s's. Now I'm going to simplify this. This is a big fraction, but it only has one term. So in this case, I'm going to split into 3 separate fractions, and this is going to be minus 10, s3 over s, and then plus 3 big S minus 2 over s, minus 14s squared over s. Okay, perfect. So now I'm just going to take up the s in each case. So this would be minus 10s squared plus 3s minus 3, and then minus 14s. Now I can do the derivative. And in this notation, if I do the derivative, I'm just going to rewrite it as dt over ds. My space is a bit limited, but let's try and squash it in there. So this would just be minus 20s, and then minus 9s minus 4, minus 14. Okay, and then once again, there's a negative exponent. So final answer would then be dt over ds would be equal to minus 20s minus 9 over s to the power 4, and then minus 14. The last one we're going to look at, so now you need to put on your grade 10 factorizing glasses. How on earth am I going to factorize this? Because now it is a fraction, there is an x at the bottom, but I can't just take it up because it is a binomial at the bottom. So I need to factorize the top, hope things are going to cancel out, and then I can derive at the end. But in this notation, I'm just going to keep the dx and the block bracket there. And I hope you've seen it by now, but this is those sums where you make a small bracket and then a big bracket, because it is the difference of cubes. I have a very calculated suspicion that one of my brackets is going to be 4x minus 3y, but let's just double check. So the cube root of this would be a 4, definitely, and then just an x. Okay, so 4x I can write there, and I know the cube root of 27 is 3, so my suspicion was true. This must be 4x minus 3y. Now, I'm not going to go slowly and explain all the things about the difference of cubes, there is a video on the channel. Please just go and search for it, and there I explain it in detail. But to get the second bracket, I just need to look at the first bracket and then square the first term, so 16x squared, multiply the two terms and change the sign, so this would be a plus 12xy, and then square the last one, always a plus, so 9y squared. Great, that's still in the block bracket. Now they can cancel, and then all the brackets just fall away. So let me just rewrite one more step. So the brackets fall away, and this is just 16x squared plus 12xy plus 9y squared. Now I can get the derivative, and this just all changes into an equal sign, and that's 16 times 2 plus, okay, so I'm looking at the x's exponent. So there's just a 1. So this would be 12y, and then x, 1 minus 1, the x would just disappear. And the last one does not even have an x. So that is my final answer. Okay, guys, I know I dumped a lot of info on you in this video. Please go back, watch it slowly, pause if you need to. Extremely important, these rules and the notation. You are going to get one first principle sum in an exam, and then 2 or 3 of these shorter sums. Please make sure they don't catch you out with this. Please try the practice video to see if you really understand, or if you need to do a few lessons again.
If this video helped you, please like and subscribe.
JMath.